Hi, today we're going to talk about forces. To introduce forces, I'd like to tell you a little about a man named Isaac Newton. Isaac Newton studied physics and math and was clearly one of the most influential scientists of all time. In fact, he was a key figure in the scientific revolution. Newton relates to forces because he's the man responsible for coming up with the three laws of motion that we'll discuss at a later time. Newton did not have the most fortunate life growing up. His father was a prosperous farmer who died 3 months before he was born. His mother remarried at the age of 3 and left him with his grandma. Newton was reacquainted with his mother again at the age of 12 when she was widowed. She pulled Isaac from school and tried to have him run the family farm. Unlike his father, though, Newton was not a very talented farmer, so his mother finally put him back into school again. Later, he went on to study at the university, where he took part in a work-study program, meaning that he worked in order to attend school. So what is a force exactly? A force is any push or pull that acts on an object. It's something that can cause a resting object to move by changing the object's speed or direction. One example that people sometimes struggle with is the idea that the floor is actually applying a force on your feet. Yes, the floor is an inanimate object, but it's still responsible for providing that force. Another example of a force is gravity pulling down on your body towards Earth. As you already know, without the force of gravity, we would all just float about. The unit of force is called a newton after Isaac Newton. 1 newton causes 1 kilogram of mass to accelerate at a rate of 1 meter per second per second. Here's an equation that we will talk about in depth at a later time. Anyhow, it is mathematically illustrated what a newton is actually. For now, just know that a unit of force is a newton, abbreviated as N. Scientists use arrows with specific directions and length to illustrate forces. Simply, the direction of the arrow shows the direction of the force, and the length of the arrow represents the strength or magnitude of the force. Here the picture illustrates a large force to the right in comparison to a medium and small force to the right. The picture also shows a medium force upward and a small force downward. The total force acting on an object is called a net force. In the figure on the left, we can see the force being applied to an object from the left towards the right, and the same amount of force being applied from the right towards the left. This means that the total net force is 0. The picture to the right shows a weak force being applied towards an object on the right, and a strong force being applied to the object towards the left. Here the net force is towards the left. We will show you how to figure this out mathematically later on. A perfect example of balanced forces is an equal game of tug-of-war. If people are pulling on a rope with the same force, there will be no change in the object's motion. These forces on the rope are balanced, and the net force would be 0. Forces can be unbalanced as well, which results in an object to move or accelerate. In part A of the picture, it shows 2 forces acting in the same direction will be added together. Part B of the picture shows if the forces are applied in opposite directions, the forces will be subtracted from each other. Part C shows that the forces are equal and opposite. This results in no net force. Combining forces are when 2 or more forces are being applied in one direction, causing a greater force being applied to an object. For example, in the movie Cool Runnings, the Jamaican bobsled team always uses combined forces as they push their bobsled down the chute together. Together, all their individual forces combine to create a larger overall force. On the other hand, we can combine forces in an opposite manner. When Sylvester Stallone played Lincoln Hawk on Over the Top, he beat his opponent in the arm wrestling championship. Here, the 2 arm wrestlers' forces were in opposite direction. Mathematically, we would have subtracted Stallone's opponent's force from Stallone's force to get an overall net force. Since the forces are unbalanced, the net force would also have a direction. This will be where we stop our lecture on the introduction of force. Please rewatch the video for more clarification or refer to Chapter 3-1 of your textbook.